All right, so in this video, 10.2, we're going to do a word problem. And this word problem is talking about a cooling tower design. And earlier in this section, it talks about um, the how the design of a cooling tower is in the shape of a hyperbola and what that is useful what that is useful for. So if you are interested in that, you can read that. But we are going to do this word problem. So real world cooling towers, the profile really is hyperbolic. So this is very real world accurate. So this is another use of hyperbolas, one that I didn't talk about in a previous video, because we're going to talk about it here. So that's cool. All right, so let's do this word problem. So it says the design layout for a cooling tower is shown in figure 11. The tower stands 179.6 meters tall, so that's this whole distance here. The diameter of the top is 72 meters, so at the very top it's 72 meters. And then the skinniest part, so it says at their closest, so that's the skinniest part here. The tower is 60 meters apart. So at their closest, that's going to be where the vertices are. So there's a vertex here and a vertex here. The vertex are always going to be at the place where the two hyperbolas are closest to each other. So if you see that like at their closest in a word problem, those are going to be the vertices. So our vertices are here. They're 60 meters apart. That's going to be important. Okay. Find the equation of a hyperbola that models the sides of the cooling tower. So we're finding this hyperbola here. Assume that the center of the hyperbola indicated by the intersection of the dashed perpendicular lines in the figure is the origin of the coordinate plane. So again, just like we've done in previous, if we assume that the center is at the origin, it makes our calculations easier. So in word problems, we can just make that assumption, right? You just make the assumption that we're centered at the origin, and then we don't have to worry about shifting anything. It makes our lives simpler, so we're doing that. Yeah. And we're gonna round to 4 decimal places. Okay. So this picture also tells us that this distance is 79.6 meters, which I'm not seeing in the description, but they're giving us that in the figure. So I'm gonna guess that that's gonna be important. This is in the figure, but oddly, it's not actually in the description. Interesting. Okay, so that's what we know. So we know that this is a horizontal. This is a horizontal ellipse, so our x term is going to be first. And yeah, again, we're assuming that the origin is right here. And we're going to have x squared over something minus y squared over something equals 1. Because we've decided that the center is at the origin, we don't have to worry about adding or subtracting anything here. And this is again, a horizontal hyperbola, so we know that the x term is first. So now we just have to figure out what a and b are. So a is always going to be the distance from the center to a vertex. Well, we were already given that the transverse axis is 60 meters long. We know that a is half the transverse axis, so a is going to be 30. So a is 30. I'm going to write that over here. So a squared, right? If a is 30, a squared is what's going to go under the x. 30 squared is 900. 30 squared is 900. So under the x, we're going to have 900. Now we need to find b. Okay, so the next thing is going to be b. So we are going to figure out what b is by using a point that we do know. Okay, so we know where the vertices are, but that doesn't really help us. We need to use another point that we know. So we're going to plug it. We're just going to have a placeholder. We're going to have a b squared placeholder. We don't know what that is, but we have points on here that we do know. Hold on, I'm arguing with myself for a second here. I just said we couldn't use the vertex, but I don't know why we wouldn't be able to use the vertex. Ah, yes, because y is 0 and this term would just go away. So that doesn't help us. We can't use the vertex. I knew we couldn't, but I wasn't sure why there for a second. So I had to think about it. Yes. So if we use the vertex, again, y would be 0 because remember this is the origin. Y would be 0. This term would go away. And so we wouldn't be able to find b squared that way. So we need to find a different point. So we're going to use this point right here. This point right here, because we know this distance, right? We know this distance. Alternatively, we could use a point down here. No, we can't because we don't know the horizontal distance. Never mind. We have one option, technically two. We can use this point or this point. These are the points that we can find the coordinates of. I'm just going to use this one actually because it's positive. So I'm going to use the positive version. So the x value of this point is going to be half of 72, right? Because again, this is the origin. So if I go this direction, it's going to be half of this distance. So we're at half of 72, which is 36. So at this point here, we're at 36 and, oops, unnecessary comma. Hold on. We're at 36 and 79.6. We're at 36 and 79.6. So that's this point. So we're going to plug 36 in for x, 79.6 in for y, and we're going to solve for b. That is the plan. So we have 36 squared over 900 minus 79.6 squared over b squared equals 1. So 36 squared is 1,296 divided by 900 is 1.44. So this is 1.44, and you can just do all that in your calculator, minus 79.6 squared is 6,336.16, and that's still divided by b squared. I just don't really have room. Equals 1. So the first thing I'm going to do is I'm going to subtract the 1.44 to the other side. So I get negative 6,336.16 over b squared. And then over here we have 1 minus 1.44, so that's going to be negative 0.44, right? 1 minus 1.44 is negative 0.44, and sorry, that's cut off. And then we can multiply both sides by b squared, so negative 6,336.16 equals negative 0.44 b squared. And then dividing both sides by negative 0.44, we get 14,400.86 3636. So b squared equals 14400.3636. Now, I'm doing this all in my calculator, and I'm keeping it all in my calculator so I don't have rounding errors. So in the next step, I'm always just doing answer divided by negative 0.44, for example. So answer and then doing the next step instead of retyping it in each time, because then you get rounding errors. So being careful to do that. So then our next step, of course, is to take the square root of both sides. So if we take the square root of the answer that's already in my calculator, I get 120.0015. So I'm going to write that over here because I don't have room. Is 120.0015. Okay, so that's B. So our final answer is x squared over 900 minus y squared over 1 over b squared. So it's not 120. It's the 14,400.3636 equals 1. Okay. So that's the answer. That's a big, nasty number, but it's a big tower, so it makes sense that this would be a big number. Okay. So that is how you find the equation given this information and given this picture. We couldn't have done it without the picture because remember, this dimension which we used was in the picture, but it wasn't in the word problem. Unless I completely missed something, but I don't see it anywhere. So sometimes if they give you a picture, there might be more information in the picture than is actually in the word problem. So make sure you're paying attention to that. If they don't give you a picture, by all means, construct yourself a picture. I feel like that always helps every time I'm doing a word problem, especially with conic sections. Always draw yourself a picture, especially in a word problem. Always draw yourself a picture. It really helps. So hopefully all of that helps give you some ideas of some strategies to use. And I will see you in the next video. This is the last video for 10.2, by the way. So see you later.